We have chain rule versions of the six trig derivatives as well. Basically, it's whatever you learned times u prime on the end, so that doesn't really change any. And the derivative with respect to x, we'll do sine of 3x squared because I think we already did 3x in another video. So we're going to make this the derivative with respect to x of sine of u, where u is equal to 3x squared. So u prime would be 6x. So in this case, that's going to be cosine of u times u prime, which is cosine of 3x squared times 6x, or 6x cosine of 3x squared. So I want to point out, we didn't take the derivative of the inside here. It stayed the same. The derivative of that gets multiplied on the outside. For this example, we've got the cosine of x plus 3, so if we let u be equal to x plus 3, this is the derivative with respect to x of the cosine of u. So u prime here would be 1. So this would be the derivative of cosine is negative sine of u, and then that's going to be multiplied by u prime. So that's going to be negative sine of x plus 3 times 1, or just negative sine of x plus 3. So that is my answer there. In this problem, we have the derivative with respect to x of sine of x squared. So my u is going to be x squared. U prime would be 2x. This is the derivative with respect to x of sine of u. So that's going to be cosine of u times u prime, which is going to be cosine of x squared times 2x, or 2x cosine of x squared. And that would be my answer. Now let's contrast that with the next problem. The derivative with respect to x of sine of x quantity squared. So in this case, the bigger picture is that something is being squared. This is actually not a generalized trig rule, this is a generalized power rule. So this is actually the derivative with respect to x of u squared, where u equals sine of x, and u prime is cosine of x. So this derivative is 2u times u prime, or 2 sine of x cosine of x. So a very subtle difference, just where you place the squared in this problem makes a very large difference for how the problem actually works out. Another thing to keep in mind is that you can actually have repeated applications of the chain rule. So it's kind of an inception style thing, the chain rule within a chain rule. So this is an example of when you might see that. The biggest thing that's going on here is that something is being squared. So outermost, we've got the derivative with respect to x of u squared, where u is equal to the cosine of 4x minus 2. Well, in this case, we need the chain rule again, because we've got the cosine of 4x squared. So I'm going to use a slightly different variable. I'm going to use a w, and we're going to let that be 4x minus 2. So this is cosine of w. So u prime would be the derivative of cosine, which is negative sine of w, and that's all going to be multiplied by w prime, which is 4. So this is negative sine of 4x minus 2 times 4, or negative 4 sine of 4x minus 2. So the whole reason we did that is because when we come over here to do the actual derivative, this is going to be 2u to the first power times u prime, and we needed that u prime. So that'll be 2 cosine of 4x minus 2 times negative 4 sine of 4x minus 2. So that all simplifies to be negative 8 cosine of 4x minus 2 sine of 4x minus 2. Now similarly with this problem, the biggest thing that's going on is that we've got a sine. So this is the sine of u, where u is equal to the tangent of 2x. And in order to take the derivative of that, we need to know that this is the tangent of some w, where w equals 2x. So u prime is the derivative of tangent, which is secant squared of w times w prime. W prime is 2. So this is the secant squared of 2x times 2, or 2 secant squared of 2x. So the derivative with respect to x of sine, coming back to the beginning, is sine of u is going to be cosine of u times u prime. So that's cosine of, now u, remember, was tangent of 2x. And then u prime is going to be 2 secant squared of 2x. So this is, if you just bring the 2 out front, 2 cosine of tangent of 2x times secant squared of 2x. And that is my answer there. So that one's pretty complicated. It's got a lot of layers to it. Now, one thing that you do want to make sure you're aware of is that this cosine and this one of these secants, they cannot cancel here because they have different parameters. If they had had the same parameter, you could have canceled them, but in this case, you cannot.